Okay, this is the P2 January 2022 paper. It's question 10. We can see this is a proof question. Proof question is really unpopular with my students at the moment because they don't feel like they've had enough exposure to them, that there's enough examples. So when we get one like this, every time you get one, add that to your memory bank of the different ways that we can do the questions. And also some of them, like this first part's really easy, so don't miss out on getting the marks for this. So what are we doing for part one? It says prove by counterexample. So counterexample simply means find a version where this is not true. If p is a prime number, then 2p plus 1 is also a prime number. Okay, if p is a prime number, then 2p plus 1 is also a prime number. Now, it's up to you. What you can do, and what I'm going to do it really slowly, and I'm just going to go through and try values till it works. So 2p plus 1, I can do 2 lots of 2 plus 1, I can do 2 lots of 3 plus 1, I can do 2 lots of 5 plus 1, I can do 2 lots of 7 plus 1, and then just keep going like that till we find one. If, as I'm going through, I don't find one really quickly, then I might stop and use my common sense and think, for example, 2p plus 1 is always an odd number. So looking at my odd numbers, are there any that are not prime numbers, like 9, like 15, like etc., etc., etc.? In this case, though, it's only worth 1 mark. I'm already going too far with it. So actually, just by doing those ones, we're going to get, that works out to be equal to 5. No, that fits in with them. That works out to be equal to 7. That works out to be equal to 11. Uh-oh, you're thinking, but then that's 15. And 15 is a counterexample, so 15 is not prime. 1 mark, you're basically going to find a value and it's going to, so I didn't need all that stuff there, but just in terms of trying to show how I might have a go at doing these generally. And as I say, we're looking for things like prime numbers. 2 might be the exception to anything that will come up in any rules for that sort of thing. Anyway, moving on to number 2, it says use proof by exhaustion. So I don't like proofs either, but I'm not too bad about the exhaustion ones because my favourite thing to do with exhaustion is try even and then try odd and see what we get going on with them. Use proof by exhaustion to prove that if n is an integer, then 5n squared plus n plus 12 is always even. Yeah, no, that's exactly what I'm going to do with this then. So if I'm going to prove this by exhaustion, let n be even first of all. So any even integer, I'm going to call that 2p, 2k, 2 whatever, I'll stick with k. I'm going to call that 2k. So they said 5n squared plus 2n plus, 5n squared plus n plus 12. So that's going to be 5n squared plus n plus 12. Let's see what that works out to be. Well, that's 5 lots of 4k squared, so that's 20k squared. Plus 2k plus 12. Well, that is even. They can't just say that's even. Really good thing to do. Factorise and take 2 out. Okay, and then I always say, well, that's 2p in this case. That's 2p, which is even. Really making it clear to the examiner that I've got that one. So I've taken half of the values I can think of. If I now take n to be odd, so I'm going to call it 2k plus 1 now. That's always an odd number. So we're again saying 5n squared, so 2k plus 1 squared plus 2k plus 1 plus 12. What happens to that? Well, I'm hoping it's going to work out to be even again, but let's just do that. Take a little bit of time over this because it is a proof. So 2k plus 1 all squared is 2k plus 1 times 2k plus 1. I don't expect you to do this in your head. I can do this in my head. So that's 4k squared plus 4k plus 1. Do it at the level and the pace at which you are able to do that and keep your accuracy here. Plus 2k plus 13. So that's 20k squared, 20k plus 5 plus 2k plus 13. Well, all of that then, we've got 20k squared, we've got 22k, and we've got 18. Perfect. Okay, that's the same as 2 lots of something. In this case, 2k squared plus 11k plus 9. Sorry, 10k squared plus 11k plus 9, which is 2p, which is even. Okay, so true for all possibilities, odds and evens. Okay, hopefully that makes sense for that one.